Hello, everyone. Welcome to our webinar about how AI can enhance observability platforms. My name is Edyta Kałka. I am engineering manager in CodiLime, taking care of projects from observability domain. With me today is Tomasz Janaszka, our AI ML expert.
Hey, hello, everyone. I'm solution architect at CodiLime, working in R&D and researching modern AI techniques that could be used in practical challenges and problems encountered in network and IT infrastructure management. Let's look at agenda of today's webinar. We will start by outlining the key challenges driving the need for AI techniques in observability. Next, we will demonstrate a couple of interesting use cases, and it will be the major part of our webinar. Next, we summarize the AI techniques used in our demos together with potential benefits. We will also touch on deployment hardness. And at the end, we will have the Q&A session during which we would like to answer the questions from the audience.
You're right. For now, let's start from a simple, small teaser trailer. We won't go into details right now, but please ask and answer yourself. Do you like such number? Would you like to achieve such number within your business? If yes, please stay with us till the end of the webinar. Before we start talking about AI, let's first take a look at a simple example of dashboard that you can find in any observability tools. I think for most of us, this kind of dashboards look familiar or similar to the ones that you are using right now. Your dashboards might be more pretty, they might contain fancy widgets, but now question arises. Is pretty makeup on our dashboards packed with data enough as an evolution for observability tools? From our point of view, it is not, and we will talk about it today. But Tomek, let's first concentrate on challenges and enhancement areas that we can list in case of modern observability platforms.
Okay, so Edyta, we discussed a lot about the problems that our clients are facing during development of in-house or commercial products. And we can summarize them as repetitive pain points, starting from the need for the higher level of proactivity and much more seamless integration of forecasted data with current and historical data. Also, we could outline that many teams still suffer from too slow retrieval of contextual data from many data sources. Also, there is still high alert fatigue, driven over by noisy and very often redundant notifications. Definitely, if we could apply some additional techniques for event correlation, that could help to surface the most likely root causes together with remediation actions, it is the major objective. Also, we noticed that the historical knowledge could be used much more efficiently in much more automatic way. So at the same time, these challenges are the enhancement areas for various AI techniques, starting from forecasting models, boosting proactivity, and using modern GenAI LLM-based frameworks and multi-agent architectures could easily help us to improve the situation awareness, more intelligent alert triggering, and also collecting data for pointing to most likely root causes for our incident and failures.
Mm-hmm. In a moment, we will jump into demonstration. But Tomek, can you first say a few words how our demo is prepared, how our environment looks like?
Let me switch. Let's say this is the old-fashioned dashboard. So we prepared what we would like to suggest. It is the environment this is the live environment, multi-site environment that we prepared using Container Lab framework. It is live. It consists of 12 routers connecting 4 sites in Warsaw, London, Paris, and Rome. Each site hosts servers running a set of virtual machines. Also, this platform is collecting the syslogs from all the devices into one central server. So whenever we will apply some analysis, the platform is using the fresh data and providing the up-to-date insights. Also, we would like to mention that all interaction with large language models are live. Therefore, some unexpected situation or delays may occur during this webinar, but we are taking this risk intentionally. This is our platform.
Thank you. Our first use case is about utilization of machine learning in case of time series forecasting. Before going into details, let's talk a little bit about time series data processing. Historically, if we thought or talked about time series data processing, it concentrated around raw metrics, aggregations, baselines, and trends. That was the core, and it mainly represented historical data or current state. Only trends were a small window to the future, but not too precise. Right now, AI ML era opens some additional doors, and future become key aspect of observability tool. So Tomek, what AI brings more to the table in case of time series forecasting, but let me narrow the context of this open question. Specifically, can you show us how this kind modern observability tool can help us reduce time required to forecast network usage down from days to minutes?
Definitely, when we are observing the network infrastructure, the key point is to observe the traffic on the links and on the devices. And we need to assure proper capacity. So here in our platform, we could see the graph of our network. All is green. In this special tab, congestion, so we can observe the congestion occurred over the last 24 hours. All is green, which means we are at the good point. There were no congestion here. But most important is what will be in the near future. So therefore, the modern platform should be equipped with the functionality for forecasting of time series, in this case for the traffic. So let me run this analysis where I can just set the forecasting period and can set a couple of machine learning based methods. When I run it, the platform should retrieve appropriate data, historical data, and train the model and to produce the forecast and also analyze the forecast, producing useful and understandable signals. So here, after the computations, we could see that we have additional tab, future congestions, and we could see that some links are orange, which means that in the forecasting perspective that we set, we can expect that the traffic will cross the safe operational thresholds that we set to 85%. But this red one link means that for this traffic on this link could cross the capacity. So here, when I click it, I can see that only one forecaster, this linear regression, is saying that in 21 days, we will have the shortfall of capacity. Other forecasters are not providing such a signals, but all of them are providing the signals about the high traffic above this threshold. Linear regression in 7 days, Hot Winter's Prophet in 16, 19 days. They are different because they are different methods. Here we could see the properly annotated charts clearly displaying when this performance issue may escalate in the future. But linear forecasting cannot be always as accurate as possible. So it is a good point to have a couple of methods like Hot Winters and Prophet. They are trying to predict the whole signals for the future, and we can just compare with our, say, threshold and capacity levels just to produce the appropriate signals. And that's the point. We need useful signals and giving us the time for the reaction to reconfigure before the problems escalate. And also such functionality could be used for capacity planning. So the platform should offer us such a data, and overall it should lead to a lower level of over provisioning that could give us savings.
Okay, summarizing, let's say it once more. This kind of platforms allows to forecast network usage in minutes instead of days. And what more, you can do it at any time, not just at capacity planning cycles.
Exactly.
All right, let's right now look at our infrastructure topology. As you can see, it is not only network, but part of it are servers and VMs. During the introduction, we showed you old version of server VMs dashboard. This kind of dashboards, packed with data and widgets, very often are not necessarily helping while solving an issue. So how can we change it? How can we better present data? How can we better observe server with the help of AI?
Yeah, let's look at this example. In our demo, we have the special tab presenting the servers and the number of running VMs on them, what is the resource allocation on them, and also we could see the free resources that you can use. But let's look at the alerts table. Here we can observe that we have 2 orange alerts, and they were acknowledged, so someone is dealing with them on other server, but here is one active alert. We could read that on this particular virtual machine, Warsaw 2-2, we have the usage of CPU over 80%. So definitely we need to overview the situation. Many platforms offer special, say, dashboard and functionality presenting the details. And here also we could see that this particular virtual machine suffers from high CPU utilization at the level of 95% during the last 24 hours. It is good also point when you have the problem with CPU to look at the RAM usage. And here we could notice that there is no problem with RAM because these pie charts are presenting various statistics over the last 24 days. And we could see there is no problem with the high RAM utilization. But this is the point. When I need another type of charts or to check another metrics, I need to check to select appropriate tab dashboards. Exactly. Or configure the widget to configure particular charts. Much more convenient is to use the chat with natural language. And for us, the chat interface is a gateway to the all functionality that the modern platform is offering. So I will be using the prepared questions just to have the nice pace of this webinar. But of course, we can modify them in this window. So first, let's present the utilization of CPU and RAM at one panel. So here we are having the request to our platform, create charts for CPU and RAM usage on this virtual machine over, say, last 24 hours. That can be different than our global setting here. So when we run it, we expect that the platform is providing us data in the form that we want. Yeah. So now we could see the CPU utilization. So we see that this threshold is crossed, and no problem on the RAM. But let's modify this query. This time, let's provide different perspective for CPU over last 24 hours. But for RAM, we would like to see over last, say, 30 days. But also for RAM, we would like to see the trend. So let's run it. So simple query, but the platform should draw us the adjusted charts. So let's see here. And indeed, we see this data in different perspective. And here also for RAM, we could see the trend. It is slightly increasing. So we could see or suspect that there is a problem with memory leak on that. But this is the case. I just prefer to have the necessary metrics and charts in one panel, just too easy to compare.
Mm-hmm. What we have seen so far is a simple usage of our AI-powered chat. Changing time horizon or enhancing charts are good examples, of course, but very often our observability platforms need more contextual information for better analysis, like correlated insights from other layer or prediction about future of resources. So Tomek, can you show us such usage of our chat?
Yeah, definitely we could increase the situation awareness just displaying asking the simple query that show resource allocation on the small server. So presenting the allocation for all other virtual machines. But let's be a little bit more ambitious. And this time let's ask which VMs will suffer lack of resources in perspective of 100 days. And we could also ask in the report just to point only to the virtual machines that are problematic or will be problematic in the future. So when I run it, the platform should, it is not the simple query for the metrics. It is rather the request for the deep analysis, looking forward and giving us the answer. And here we could see the simple report pointing to the problematic virtual machines in the future, together with when we could expect the problem with performance. And also this report is backed by a set of charts computed for each virtual machines, properly annotated. So we could easily, for instance, for virtual machine, let's say 2-8, so high load regarding CPU will be in 10 days and lack of CPU in 67 days. Using the same, say, forecasting engine, we could extend the situation as our virtual machine is has a problem with CPU, but maybe on the server, other virtuals will have in the near future the problems, similar problems.
Okay, Tomek, let's right now check if there are other problems around the corner. Like, for instance, congestion on the link carrying traffic to our server. In this case, we would need additional insights from network layer.
Yeah, definitely. So we integrated here into this chat also our React agent, our previous module, that is GenAI LLM-based net chat assistant for network troubleshooting that is able to communicate with network devices and retrieve the data from them. So this module was presented during AutoCon 2 conference and in one of our previous webinars. So we integrated it so we could just ask the question about other layers. For instance, we could easily list statuses of interfaces on this router forwarding the traffic to this server. We could easily check, for instance, whether the other servers, like server in Paris or London, have some problems with connectivity to our affected server. So let's run it. So this time the agent is logging into particular servers and conducting the ping. And after that, we should receive a nice table presenting that there is no problem with connectivity to our server. And also with some statistics about runtime times. But you ask about traffic on this particular link from this router to our server. So we could ask simple query like here, show traffic to server over last, let's say 7 days. So let's run it, and the platform should quickly present us the appropriate charts. So here we could see that we have the traffic in both directions on these links, together with the capacity of the link and the safe operational threshold set on that. So we extended our situation awareness also using network layer.
Summarizing, what we're really enabling here is a contextual dynamic dashboard accessible through a simple chat interface. It brings critical data in one place. So instead of switching between fragmented dashboards or going over big dashboards packed with data, your team can right now review everything in one compact view. It is faster comparing to drill downing between static dashboards while looking for an answer that is not always there. Of course, everything depends how your static dashboards and your still drill downs are defined. In simpler cases, the gain can be from hours to minutes. In more complicated cases, it can be even from days to minutes. It is also more efficient in case of issue resolution. As mentioned, everything is one compact view with the whole research history. Such history would be lost while switching between dashboards. Let me also mention one more thing. Cole Newport from Georgetown University, in his book Deep Work, says that each person requires different amount of time to pivot from one task to another. The same concerns each click with context switching. So switching between dashboards, logs, runbooks, ticketing systems cost us additional time. It is around 5 to 25 minutes for each such interruption. We can call it gray time or we can call it waste time before any analyst can be reoriented on original task.
Yeah, so very nice scientific summary of the context switching problem. Yeah, I can add that it is also much simpler for the new engineers.
Yes, of
The
course.
functionality.
All right. So far, we talked about predictions, meaning what and when can happen. But Tomek, how our tool can help us if any failure occurs now?
Yeah, definitely the power of model observability platform is how they can help us in case of the failures of the incidents.
Exactly.
So we will demonstrate how we imagine that the platform could behave. We will introduce the failure in our infrastructure. Not a very simple failure, but we will provide 80% packet loss on one of the interface, Ethernet 1, in router PE1 Warsaw, affecting the traffic to CE Warsaw. So we mentioned before that our platform is able to see on the syslogs from all the devices. So now I will simulate this failure. And let's see what our platform do. So here, the platform noticed that there were new errors on those devices. This is the error count and unique error count. So this is the after the threshold, the special agent was kicked off for analyzing the logs. It detected that we have the problem with BGP session instability, and also with the nice description stemming from the messages on the errors. But this is the first point, just to raise new alert. But at the same time, our platform just tries to resolve it, providing us the hint or most likely root cause. So it took this log events, aggregated them, removing repeated or condensing the repeated errors and normalizing messages. After that, this concise log were put to LLM asking for potential root causes, as we could see here the answer of this analysis, and also with some proposal for resolution actions and checks that we could perform trying to deal with that alert. And at the end, this platform, of course, is adding this alert to the global alert table. And not only we could read the properties of this alert, but also we could see the quick analysis of likely root cause.
Mm-hmm. What Tomek has already showed you and what historically log analytics tool provided is log normalization and aggregation based on text similarity. Log grouping based on text similarity is helpful to some extent and of course can be used as input for root cause analysis. However, with AI support right now, we can go further, we can be more precise, we can better mirror the reality. For that, we can use semantic clustering. So we will have log grouping based on meanings, not just text similarity. It can lead us further to more accurate root cause analysis, especially in more complex cases, where, for instance, we've got complex failure impacting multiple protocols or components, or when we have multiple failures occurring concurrently.
Yeah, definitely the platform should offer something much more sophisticated. Therefore, here we have the additional button, Advanced Root Cause Analysis, that will switch us to the dashboard presenting the log events. Here we could see it in the, say, a raw format and also with the parsed format. together with some statistic about what is the number of unique errors or unique nodes. And also we could see here the results of automatically triggered analysis. But you mentioned that what if the problem is much more complex? That's why we prepared the clustered, another type of analysis, clustered log analysis. But let me explain how it works. So here we took the aggregated log, and for each message we are applying the GenAI embeddings, having the vectors. Those vectors are the major feature for machine learning clustering. That using those vector is able to, based on the semantic similarity of those messages, to group these events into separate buckets and process them separately. So let's demonstrate it. When I click it, here I could also select the number of cluster. When I run it, all this processing is being now done, and we could observe that each cluster is analyzed separately. So this is the classic implementation of divide and conquer rule. When we have the complex problem, then we are trying to divide it into a set of simpler ones and to process them separately. We could expect that the results would be much more accurate and precise. And the clustering should, we expect from clusterings to separate the different aspects of the same incident, or to separate the failures or incidents that are occurring concurrently. So here we have the answer, a result of our analysis, when we could see that for each cluster, how the messages were grouped, and for each cluster we could see what is the potential root cause and what are the resolution actions similarly, but separately for each clusters.
Okay, Tomek. While log events are foundational for root cause analysis, often relying solely on them can be misleading. What I meant? Without additional context, like metrics, configuration changes, state of devices, history of similar failures in the past, it can lead to incomplete or even wrong conclusions. What can we do about that?
Yeah, that's why we prepared another type of analysis, which we called augmented analysis. So let me explain on the slide. This time, we implemented the coordination agent that is taking the information from the log and knowing what AI agents are in our platform and could deliver us additional data, is trying to make a query plan for additional data and ask particular agents for those data. When it collects them, then using properly crafted prompt to the LM, we are asking for the root cause, but having much broader context. So let's demonstrate it. When we click augmented analysis, we could observe that our agent is collecting additional data about how those two nodes are connected. Also is checking how what is the statuses of interfaces on them. Next is trying to conduct pings from both sides to check whether there is a connectivity problems or not using ping. But this is the BGP problem. Therefore, it is asking about the status of BGP on those routers, together with BFD used for detecting the connectivity issues. And in the last point, past ticket details collection, we are also asking our internal knowledge base about the past resolved tickets having similar symptoms. And all this data together were used to identify the most likely potential root causes, as we could see here, together with some probabilities, and together with the all additionally retrieved contextual data, as we could see here. Yeah.
All right. For demonstration purposes, we perform some steps of this analysis manually. But in a real-world scenario, it can be fully automated. As soon as new alert is triggered, the system itself can execute augmented analysis behind the scenes and provide not just notification, but comprehensive outcome supporting data use in analysis. This shifts value from just another alert to actionable insight.
Yeah.
Tomek, Can you summarize right now what AI techniques were used during our webinar?
Yeah, it is. So we started presenting you a couple of machine learning methods for time series forecasting in the context of traffic and resource utilization on servers, giving us the proper signals early enough to react for the escalating problems. Next, we presented how to use chat to construct to gather necessary data in one, say, dashboard per hour incident that we are solving currently. And also we demonstrated how to process log data, how to augment the data, how to extend the context, and finally to ask LLM for most likely root causes in our problems, also including the clustering based on semantic similarity, just to make the problems, complex problems, simpler. Yeah, that was our demo. So quite a lot of knowledge in such a short time.
All right, Tomek, can you show us also some statistics and reported gains thanks to the use of AI?
Yeah, there is ample evidence that AI is not a hype. It could really bring values across industries. So, for instance, the Forrester study commissioned by IBM found that after integration of AI Ops with the observability platform, lowered the mean time to repair by 50%. JP Morgan reported that AI-driven event correlation slashes the troubleshooting time by even 75%. And another big company, Omega Healthcare, and their integration of conversational AI into operational workflows yielded 30% of rate of on investments. So these figures are impressive from the business point of view, and renders the questions of if obsolete much more imperative now is how to design, how to architect, how to integrate, and how to scale AI techniques to maximize their impact.
Okay, but Tomek, can you right now mention about deployment challenges? AI ML world seems perfect, especially looking at such numbers, but we know that perfect thing does not exist.
Yeah, it is quite challenging because first point is just we need to protect our data about our critical infrastructure. So definitely we need to assure the infrastructure for our own LLM instances only for our, say, purposes without sharing our data. So it means the cost of the infrastructure. And also we need to consider some licensing, because if you would like to use LLMs for observability data, especially for in the network and IT infrastructure, then we rather look at the large language models highly capable of in reasoning. So that means usually much more expensive models. Also, testing is not that trivial because the LLMs are not deterministic. Therefore, there is we cannot just write simple assertions of the output because they could provide right, say, answers and hints, but in different form. So different frameworks we need to use for effective testing. And also we need to support the proper availability of LLM service.
We experienced that.
Because it is the major component of many AI agents.
Mm-hmm.
And even during preparing this webinar, we suffered from the failure on OpenAI, the 10th of June. So therefore, after that, we decided to integrate also other models. So here we have a lot of models that we could use, and even switching between the analysis. So the good point is, of course, when one service is unavailable, then we could use another. But also using performing the same analysis, we could use different LLMs and we could receive different hints for the root causes. So in some cases, one model could be better than another.
All right. At the end, let's mention 3 the most important takeaways. What we have seen so far, AI techniques can greatly enhance observability platforms. I think no doubt here, and we proved that today during our webinar. Please remember that there is no one perfect AI solution that can solve all of your problems. Any AI technique, model, algorithm, framework needs to be properly selected and adjusted to the specific needs you might have. And at last, if your organization lacks appropriate AI knowledge or skill set, please think about partnering with someone that can help you and make your life easier. And of course, you can think about partnering with CodiLime. Thank you.
Okay, thank you. So we covered all the